Let's recap what we have learned so far. So whenever we want to do typecast, you want to make sure the type you're trying to cast into can really be fulfilled by the dynamic type of the variable. And we actually summarize. Let me just remind you this diagram over here, which is very important. You can see this diagram here. Given a particular hierarchy, you can actually divide all the classes in the hierarchy into 4 categories. And whenever we talk about typecasting, you have to divide into 2 different stages. Compilation, whether or not the typecast will actually compile, and also if it compiles, whether or not it will actually run into the so-called class cast exception. And again, you might run into the class cast exception if the dynamic type cannot really fulfill the class type you want to cast into. For example, the dynamic type is actually Samsung. If you want to cast that into Android or any of its ancestor classes, in that case, it would be okay. You wouldn't run into the exception because Samsung, being the descendant classes of the class type you want to cast into, can definitely fulfill their expectation. On the other hand, if you're trying to cast Samsung maybe into if you're trying to cast into maybe one of its descendant classes, in that case, you will run into a class cast exception, because in general, you just cannot fulfill the expectation for one of your descendant classes, or you simply cannot fulfill any of the classes that has nothing to do with you. They are more like your siblings. Okay, so that's something we actually spoke about in the earlier part of the module. If you got any doubts, you should really refer to them. Okay. Let's now see what we want to talk about for this current video. What we want to do is, we know that the compiler is actually unable to infer about the dynamic types for any variables. So the compiler is unable to tell us, if you try to do this cast at the compile time, you might run into trouble. So you wouldn't, so you shouldn't compile. So the compiler is unable to do so, because we said before it's an undecidable problem for the compiler to actually infer the dynamic type. So what we can do as a programmer is to really do some manual checks, to really check to see if you really want to cast into this particular type. You want to make sure at this point at the runtime, the dynamic type for the variable can really fulfill the expectation for the cast type. That's what we want to do. And we got to use the so-called instanceof operator. Before I introduce about, the idea is pretty straightforward if you really have followed along the logic that we have described so far in the module. So what I would like to do is, let me just go over some examples first, and I'll introduce the instanceof operator, and then we'll do more examples. So that'll be how we learn it. Let's see example number 1. Let's use the simplest, our familiar student hierarchy example over here. Okay, let's take a look. And let's see the first line over here. So the first line, we declare Jin with static type students. Let's now annotate it on the diagram. So students is over here, and its dynamic type is non-resident students, which can fulfill the expectation for its static type, because it's a this is a descendant class of that. And let's now put it here. So that's the dynamic type, right? You should always actually try to annotate whenever possible to remind yourself what's the static type and what is the dynamic type for the variable you're trying to reason about. Okay, so that's about the first line. And then here we are now showing to you how to use the syntax for instanceof. So let's look at its syntax. You can think about the instanceof operator is more like a binary operator. So you can think about instanceof is at, in the middle over here, and you got the left operand and the right operand. The left operand over here is always some expression that would denote some objects in the memory. Okay, so over here, so it's going to be some expression, but typically just some reference variable, but it could be some object expression using the dot notation. So expression, so you can use the dot notation if necessary. Remember about the navigation, like using aggregation that we spoke about in the earlier lecture. That's what I meant by expression. For example, you can say Jim.spouse, if spouse is just another person, right? Let's say expression denoting and objects in the memory. That's the left hand side. The right hand side, it's very straightforward. It's simply just going to be a class. Okay, so here, oh, I drew a little bit better. So that one there is just going to be a class name. Just going to be an identifier for the class. Okay, and now what's really the meaning for the instance of? Let me give you the very intuitive meaning that'll be sufficient for you to do all the reasoning. Okay, so let's see. Let's use orange over here. So now if I box this particular instance of expression over here, so what it will do is really asking the following question, and I will phrase the question in different ways. They are actually equivalents, so you will see exactly what I meant. So what I said in the video, and also what's really presented in the slides, I might just use different way of phrasing the same question, but they're really equivalents. Okay, let's now think about it. So number one is, can the dynamic type of gym, in this case non-resident students, fulfill the expectations of the right operand over here, right? So this is a right operand. Let me put a star over here. So that's a right operand of the resident students. So the resident students, and this is really the star I'm talking about, right? Okay, that's the most intuitive way to understand what's going on, because if it doesn't fulfill, in that case, if you simply do the cast over here directly without the guard of the instance of operator, like what we saw earlier, you're gonna run into class cast exception. Okay, so let me just say over here. So this part we know very well from the earlier part of the module. Class cast exception if executed. Class cast exception if executed. But by using the instance of operator, as we'll see, because the answer to the question I'm trying to phrase right now is going to be false. So that means the if statement here can really prevent this particular cast from happening. But I'm just trying to say, from earlier learning, we know that if we try to execute this particular line, we're going to run into class cast exception. Okay. Let's now try to rephrase the question a little bit. Okay, that's number one. What about number two? Okay, so number two, let me highlight the key phrases for question number one. Dynamic type of gym over here, and also resident students. So that's the type we are trying to, the right operand of the instance operator, and we say fulfill the expectation of. So now for this fulfill the expectation of, we can actually phrase it in two different ways. They are actually equivalents. Either we can say is, how can the dynamic type of gym fulfill? Okay, is dynamic type of gym a descendants of resident students. Okay, so that's the first way to phrase it. Okay, is it a descendants of? Descendants of. Right? If a type is a descendants of another type, so that means this type has at least as many code accumulated from there. So that means whatever that's expected from this class over here, it will be fulfilled by this class over here. So that's the second way. Okay. For the third way, it's going to be just the symmetric way, right? So let me put it number three over here. So number three, let me put it here, is resident students. And let me put a star over here, right? I'm still talking about the right operand over here. Is resident students an ancestor of the dynamic type of gym? It's really asking the same thing, because hopefully you can see that an ancestor of over here. If the resident students over here is an ancestor of the dynamic type, in that case, this should be able to fulfill its expectation, but in this case, it is not. So this is so in this case, resident students is not an ancestor of non-resident student. You can see their sibling, right? So that's why this answer will also be no, right? Excuse me. Let me recap. So we are basically asking three equivalent questions. I would say try to understand in this way first, and then from there you will be able to formulate it using either 2 or 3. But they are all equivalents. So you might see in my slides, I try to use I forgot which one, but when I usually when I actually mention in the video, I will simply say whether or not this is an ancestor of the dynamic type. That's what I said in the earlier part when I talk about typecasting. So I might just remain consistent. But in the slides, you might see I've rephrased it in another way, but that's definitely equivalent. So they don't get confused. So either 1, 2, or 3. Okay, and then either 1 or 2 or 3, we know that the answer is going to be false, right? And the instance of is going to give you a Boolean expression. It's going to give you a Boolean evaluation. Right, so this is going to evaluate to false. False. Okay, because let me try to use the answer to 3. Because the resident students is not an ancestor of the dynamic type of Jin, which is non-resident students. Jim's dynamic type, right? It's simply going to be false. And if this expression over here is actually false, that means we don't really get to execute this line. And we know that executing this line is going to run into class cast exception. So having this instance of evaluation and rapid within the if branch is very valuable. So it's really the safety net that we create at the runtime as a programmer. So if this is actually evaluated to false, you can see we are trying to check this before we actually cast it, right? It's let me just mention one more thing over here. You can see over here. Let me just do over here. Okay, so this part is really what why the whole thing will actually work. So this already is checked in the if branch. So we know that at the runtime, if we are able to reach this line to do the typecast, we are pretty sure that the dynamic type of Jim at this point will be able to fulfill the expectation for this, because otherwise this is going to return false, and then we never get to execute this line. So that'll be the logic. All right, so that's about the instance of operator. I think I already talked about the syntax, about the two operands, and also really what's really the rationale of writing the code in this way. All right, the second example, maybe I wouldn't need to repeat. I can simply leave that to you, but I will just mention one thing over here just to help you. When you study this example over here, I want you to notice two things over here. So number one, over here, you can see basically we are really asking. Let me just use question number one, what I said. Can dynamic type of a phone over here, right? A phone fulfill the expectations of the right operand over here, right? iPhone 13 Pro, right? So that's the right operand. Fulfill the expectations of, right? That's question number one. And then you can see using the same type over here, we are basically checking before we do the cast. And as you will see, this particular cast, executing this line. Okay, that's also something we saw earlier, which I assigned to you as an exercise. Hopefully you have done that. Executing this line will cause a class cast exception. Okay, you want to know about these two. And then in this case, is this going to evaluate to false to really prevent this line from being executed? Indeed. And all you gotta judge would be static type over here, which is smartphone, right? And also you got Galaxy S21 Plus, that's the dynamic type over here, right? And what you're really trying to cast into over here is iPhone 13 Pro, and you're simply checking to see whether whether or not the cast is actually safe. So iPhone 13 Pro, right? So what we're doing is, when you are trying to actually cast over here, would this be a valid cast? Would it compile? It would compile because a phone has a static type smartphone, and you're trying to cast that into iPhone 13 Pro. So it's a downward cast, so that'll be okay, right? And then can this cast work at runtime? And we simply check to see, can the dynamic type of a phone, which is Galaxy S21 Plus, can it fulfill the expectation of iPhone 13 Pro? It can only fulfill if either this, well, equivalently, we can either say this is a descending class of that, or we say this is an ancestor class of that. Neither is the case. So that's why you will simply evaluate to false. In that case, we actually prevent this line from being executed, right? So that's the same logic as the first one, right? So again, review this one very carefully about the 3 questions that we are basically asking in the instance of operator. So the logic has just been consistent, as we have been saying from the earlier part. All right, let me now just, if you go back to the slides, before I go on to talk a little bit more to summarize the rules, you will see that, so these are the 2 examples I just have spoken about, okay? And this one here as well, okay? So over here, I want to mention to you. So here I say dynamic type is exactly iPhone 13 Pro. So that's a little bit inaccurate. It should be is a descendant of iPhone 13 Pro. So I will fix the slides. So when you download the slides, it will be fixed. It should be is a descendant of the type we are checking over here. Okay, just to remind you. All right, so let's now talk about the instance of operator. Let me just do a little bit of summary here. Okay. So what we're really talking about is whenever you're creating some objects OBJ with a particular static type and also with a particular dynamic type. Let's say we are doing that. So A is the static type of OBJ. And also we got B over here is the current dynamic type of OBJ. Okay. Let's say we got, in order for line number 1 to really compile, let's review, right? So basically, you should really ask whether or not this will compile depends on whether or not B can fulfill the expectation for A. In this case, B is a descending class of A. So yes, so line number 1 should compile. That is summarized over here, right? There's something about the substitution rule that we spoke about earlier. And this line over here is really meant to be a safeguard. So let me just put it here. So this over here is meant to be a guarding constraint. So let me write it down. So this is really meant to be as a guard constraint to prevent a class cast exception. To prevent a class cast exception. Okay, so you can see here, I just say question mark. So I'm just using the same type over here, meaning that before we actually do this one over here, so this one we might run into class cast exception if the dynamic type of OBJ cannot fulfill the expectations of the question mark. Right, so that's really important. So cannot fulfill the expectation of the question mark. So this is really the type we are checking. That's the type we're trying to cast into. So they should really match. Otherwise, you're checking the wrong thing. Okay, so this part over here, and also the dynamic type of OBJ over here, right? It's really important for you to see every point that's actually involved. And then, so as we said earlier, what would be the meaning of checking this over here? right? This part over here is really checking to see exactly this, because we might run into class cast exception if dynamic type of obj cannot fulfill the expectation for question mark. So we are checking exactly that in this instance of check over here and wrap it within the if. Okay, so this one over here is really asking, can dynamic type of obj fulfill the expectations of question mark. Okay, so that's exactly consistent. Fulfill expectation, and we talk about dynamic type, and also we talk about the type that we eventually want to cast into. So you really want to compare this condition over here and also this condition here. This condition is telling you under what circumstance can you run into class cast exception. And here we are checking the same condition just to make sure if this condition that can cause the class cast exception actually evaluated true at this point, we don't do that in the we don't do the cast. Otherwise, we might run into class cast exception, right? So you really want to, let me just circle them. You really want to make sure you compare these two conditions very carefully. This one over here, and also this one over here as well. Okay, this one here. Okay, both conditions. All right, so that's about the summary over here, and you can definitely also try to see about the cast itself. So line number 3 is just like a revisit of the points. What does it really mean? When we want to do this cast, it will compile. That means obj based on its static type, right? Based on its static type A, you can either do upward or downward casting to its ancestor or descending classes. And then you'll run into class cast exception for exactly the reason I just reminded you over here. Right? And also for line number 2, this part over here is also what I described over here as well. But you should always remember the 3 possible ways that we can ask the question over here, which are all equivalents. Okay, so that's about the another walkthrough for the syntax for the instance of operator. Okay, let me go back to the slides over here, and then let's now do more example. Okay, let's do 2 more. And I think you can see here, this we want to check to see in the instance of over here in the slides, we're going to check if the dynamic type of V at the moment of being checked is a descendant class of C, right? So you can see this part over here is really question number, let's see, descendant class, so that will be question number 2. And what I usually said in the video is question number 3, but they are equivalents. They are the same, so don't get confused about it. You should really know which way I'm talking about, right? Both ways are valid. Okay, let's now go over 2 more examples, and maybe just 2 more. Okay, quickly. Okay, let's say we got this line of code. We got smartphone, my phone, and the new Samsung, right? Let's see what the corresponding static type and dynamic type is. Static type is my phone over here, smartphone, and dynamic type is Samsung, which is over here. And now we want to see just we're asking very simple question over here. We are basically asking this: my phone instance of Android over here. And it's going to be the same instance of, you can see the left operand is always my phone, my phone, my phone, my phone, my phone. We are just modifying the right hand side over here, right? So we are just trying to see what to what extent can the dynamic type of my phone can actually fulfill the expectation, right? So here, for example, here, let's see here, this one here, just to remind you, can dynamic type of my phone fulfill Android? And here is can it fulfill Samsung? Can it fulfill Galaxy S21? Can it fulfill iOS? Can it fulfill iPhone 13 Pro, right? That's what we have. Let's check one by one quickly. For the first one, let's see the first one. The first one is Android. Android is actually here. It is the ancestor of Samsung. So Samsung can definitely fulfill Android. So this is okay. So I'll put a check over here. And of course, if you reveal the block over here, you will see on your slides. So this will be okay. So that's true. Oh, when I say, so if you can fulfill, that means it's going to evaluate true. It's actually very important to see. The instance of operator will always give you a Boolean value. So in this case, that will be true. What about the second one? Can it fulfill Samsung? Can Samsung dynamic type fulfill itself? Yes, indeed. So that will be okay too. So that will be also a check. Okay, let me reveal that. So that's also true over here. Okay, let's go on. And then what about this? What about Galaxy S21? Can Samsung fulfill Galaxy S21? It cannot, because Galaxy S21 is a descendant class of Samsung, which means potentially in the future, in the near future, Galaxy S21 might introduce new attributes or methods which cannot be supported by, which cannot be supported by Samsung. So that's why it cannot be, right? So this part over here is going to be no. So that means it's going to evaluate to false. Okay. Let me just do a little bit better. And you can definitely also look at the explanation that's in the comments. Right, so this one is going to evaluate to false. Okay, let's do two more, and then I'll leave the last example as an exercise for you. So what about iOS? Can Samsung fulfill iOS? The answer is no, it cannot, because well, the simple reason is iOS is simply not the ancestor of Samsung, so that's why it cannot fulfill. As easy as that. We'll put it this way. It will only evaluate to true if you say instance of Samsung, instance of Android, and also instance of smartphone. These are the only three that will actually return true. Okay, so let's now try to highlight it. So this part over here is the only part. Let me see if I can do better. Okay, hopefully that might be okay. It's actually hard to draw. Anyway, so let me just use this. So these are the three classes that's actually going to return true for the instance of. Only these three. Okay. Only these three classes will have here it will be my phone, right? Will have my phone instance of, and then here I put some underscore as a placeholder, either this one, or this one. Evaluate to true. Evaluate to true. Because they are exactly the ancestor classes for Samsung. Okay, and if you see iOS over here and also iPhone 13 Pro, they will all evaluate to false because they are not the ancestor for Samsung. They are simply not, right? Only these three will actually evaluate to true. All right, so hopefully that makes sense, and you can also see the hints over here. And the last example over here, I'm gonna leave that to you as an exercise over here, right? You're gonna apply the same logic and see which one is actually going to do the cast. It's actually very important for you to complete. All right, I'll leave that to you. If you got any doubts, you can reach out to me. All right, so that's about the instance of operator. I think that's about it for this week. We are running out of time, but I think we have covered quite a bit of tricky stuff about typecasts and also instance of check. You really want to make sure you review them carefully, and then next week we'll continue with the inheritance topic, hopefully for another 1 hour or so, and then we are done, and then move on to the next topic.